Bé, moltes gràcies. La següent ponent serà l'Adriana Di Dato amb el títol Black Holes in Higher Dimensions.
First of all, I want to thank you for giving me the opportunity of introduce you this special black hole. Why are special? Because they live in more than 4 dimensions. But if I perceive only 3 dimensions, why I'm studying things in more than 4? Well, in a minute this will be clear, but I need to start from Newton. In Newton's universe, I live in 3 dimensions, and the universe is flat, and for example, a mass is attracted to another massive body to a force that we call gravity. But it's not that simple. In fact, and Einstein knew it. In fact, in the Einstein general relativity, time now is considered as another dimension. So we live in 4 dimensions. And the source of gravity is the mass that occurred space-time, the 4-dimensional space-time. So a planet, for example, turns around the Earth or what else due to this curvature. So how comes the black hole? Because if, for example, I start with a very massive star and this star starts collapsing, the curvature of space-time grows and grows, and at the end I have a black hole. But what is a black hole? A black hole is a region in my space-time that where gravity is very, very strong. So if I pass a special coordinate that is called event horizon, I get into my black hole and I cannot escape. Even light, that is the faster thing that I know, cannot escape. So it's a one-way in nature. But what we know about black hole? We know that can have a mass, a charge, can rotate. But for example, we do not say a word about the region inside a black hole. In fact, as I said before, if I pass the event horizon, all the information is lost for me, that I am outside. So unfortunately, there is no experimental test about a black hole, but in my opinion, yet in the future, maybe. So again, it's not that simple. In fact, gravity is very good to describe the universe, but it's not good enough. Near the event horizon, for example, occurs some quantum effect. So I need a theory that concerns quantum and gravity theory. And for example, a theory that explains both of these theories is string theory. And string theory is consistent in more than 4 dimensions. So this is the reason why I'm studying things in more than 4 dimensions. And well, again, if my universe is in 5 dimensions, for example, that I have new physics, new types of black hole, new shapes for my black hole. For example, I can have a black hole as a ring or a black Saturn, as you can see here. So this type of black hole are impossible in 4 dimensions. So I have no counterpart of this type of black hole. The dynamics is very different, so I can learn a lot to let my universe be, for example, in 5, 6, or what else. So my message for you is this: if I let my universe to be with more dimension, I get into very difficult trouble to solve the equation and what else. But the physics that I get is very interesting and is waiting to be studied. Thank you.